So if we want to separate the insoluble solutes from the solvent, we can use filtration, we can use decanting, but sometimes the particles of a solid does not settle down, because in a decanting first the particle must settle down. So sometimes the particle remains suspended and does not settle down. So we have to use a technique which we call centrifuging. Like a solid particles are very tiny solid particles and they are suspended. Like you have mud. So in a mud, a very fine particles are there and they remain suspended in water, which does not make a clear solution. So it takes a lot of time to settle down. So for that, to speed up, what we use, first we use a technique of centrifuging. What is the term centrifuging? So basically in a centrifuging, what we do, it's a simple centrifuging machine. So what we do, we take a mixture, like this is a mixture, and it is also for insoluble solutes, but this is for very small particles of insoluble solute. So the red spots are representing the particles which does not settle down easily. They will take lot of time to settle down. So how we can speed up this, how we can quickly make them settle down. So for this purpose, we use this centrifuging, a machine. A technique is also called centrifuging, and the machine is also known as centrifuge. So when you move this at a very high speed, so what happened when it is moved at a very high speed, the small particles, these tiny small particles will settle down. And when they settle down, because they're moving at a very high speed, so the solid particle settle down. You can see at this point, when we rotate at a very high speed and allow it to settle down, so you can clearly see these solid particles, they settle down. And when they settle down, what we can do, we can use decanting or we can use a filtration to separate the solid from the solvent. Is it clear? The concept of decanting. It is normally used for very fine particles, the particle which take lot of time to settle down. So what we do, we take a centrifuging machine and we rotate them or we move them at a very high speed. So when we move them at a very high speed, what it will force the particles to settle down, and then we can use a decanting or filtration to remove this solid from the solvent. Is it clear? Centrifuging. Any question or a doubt related to this part? So if we have basically the three techniques which we can use to separate the insoluble solid, if I summarize this part, from the solvent, so the technique which we can use, it can be filtration, it can be decanting, it can be centrifuging. Is it clear the difference between the three techniques? But all of them can be used to separate the insoluble solutes from the solvent. Example, the diagram shows a muddy water can be purified. So a muddy water is there. Muddy water means it contains solid particles as well. So which process of muddy water purification is shown? You can use the screen annotation to highlight the answer. Yeah, use screen annotation so I can also see your answers. So this technique is filtration because we are separating the insoluble solid from the mixture. So that's why C is the right answer. Now, if we want to separate the soluble solute from the solution, so we can use what we can use a technique which we call evaporation. So what happened in evaporation? This technique is used to separate soluble solute from aqueous solution. The term aqueous means something which is mixed with water. We call that as an aqueous solution. So if you want to separate a soluble solute from aqueous solution, aqua is the term used for water. So you can write solution or you can use the term aqueous solution. So what we simply do, we take a salt solution and we heat. So when we supply heat energy, we have a salt solution. When we supply the heat energy, the solvent will escape as it will evaporate, and what we are left with the salt, and we call that as a residue. This technique is known as evaporation. So to separate the soluble solute from aqueous solution, we can use evaporation. Is it clear, the technique of evaporation? That the separation of a liquid and a dissolved solid by heating the solution, the liquid will evaporate completely, leaving behind a solid, and that solid is a residue. Is it clear? So you can also perform this simple experiment at home. You can have a salt solution and you supply heat energy until all of this liquid, the solvent escape, and you're left with, yes, salt is dissolved. This is a dissolved salt. The dissolved salt, this is work for dissolved salt. I mentioned in the beginning that separating a soluble salt or a dissolved salt. So when the solid is dissolved in solvent, when you supply heat energy, the solid cannot turn into vapor, but the solvent turn into vapor. When all of the solvent escape, you are left with the dissolved solid, and that dissolved solid which is left behind is known as residue, and this technique is known as evaporation. Yes, any doubt? Abdullah, Heather, Mirab, Muhammad Hatem, Saim. Yes, Abdullah.
Sir, but if we will dissolve salt in a
Mhm.
solvent, it will
Mhm.
just like disappear, and we can't even feel the salt. I mean, it's just disappeared.
Yeah, it does. It disappear and it actually break down into smaller particle. But when you supply heat energy, the liquid molecules start to escape, and the solid particle again come together, and it will reappear. This is what happened in evaporation. when you make a salt solution, basically why you are not able to see the salt as a solid, because the particles separated from each other and very fine particles are there, so we are not able to see them. But once you supply heat energy, the liquid will start to escape as it evaporates, and the solid particle, as the space is minimum, they come together and they are left behind as a solid or residue. Is it clear, Abdullah Sarfraz?
Yes, sir.
Okay. But again, evaporation is, it will take lot of time and it take lot of energy to just simply remove all of the liquid. So to save the time, to do in a short time, so what we can do, we can also use a technique called crystallization. It's a similar technique, but it is actually saving time. It does not take lot of time compared to that of evaporation, because in evaporation you have to remove all of the liquid until all the liquid escape and you are left with solid, and that solid is known as the residue. But if you want to save time, do it in a short time, we can use a technique which we call crystallization. So what we do in this technique, in a crystallization, first we have a salt solution. So you have to learn the steps of crystallization. The first step is heat and concentrate the solution by removing some water. So first what we did, we heat and concentrate the solution by removing some water. We are not removing all of the water, we are removing some of the water. Like example, you have a container and that is filled with a salt solution. There is a dissolved salt, or a salt is dissolved. So this is a container which is filled with a salt solution. Now what we do, the first step, we heat and concentrate. So we supply heat energy. When we supply the heat energy, as the liquid will evaporate, some of the liquid will escape, not all, we are not removing all, otherwise if we remove all, we call that as evaporation. But we remove some of the liquid. So some of the liquid is escape, and we call that as a concentrated solution. Now what is the advantage or what is the benefit of this concentrated solution? The second step, we will cool down the solution. What is the purpose of this cooling down the solution? Because when the solution is hot, when you evaporate the liquid, the solution is hot. Hot solution or hot substances can dissolve more solid. But when you cool down the solution, the some of the salt will crystallize. The term concentrate the solution means when we reduce the amount of the solvent, when we decrease the amount of solvent, we made a concentrated solution. Like it contained more solute and less solvent, we call that as a concentrated solution. Second step, we will cool down the solution. What is the advantage of a second step? That cool down the solution. So when we cool down the solution, some of the solid will appear. Why some of the solid will appear? Because in the beginning, it can dissolve more salt because there is a greater amount of salt in it. When we remove the liquid, when we evaporate the liquid, now it cannot dissolve too much, as it cannot dissolve too much because small quantity of a liquid is there. So when small quantity of the liquid is there, we will cool down the liquid. So first we supply heat energy and concentrate the solution. So this is a concentrated solution. hot concentrated solution. So when you cool down this hot concentrated solution, it will cool down, and as it cool down, some of the solid will crystallize, not all, still, but some of the solid will crystallize because it cannot dissolve too much. As the amount of a solvent is less, the amount of solute will dissolve less, so it will crystallize or it will cool down. So when it will cool down, as this crystals will appear, so what we can do, how we can remove this? So the third step, we will filter to remove the solid from the mixture or the solution. So this solid, after filtration, which is left on the filter paper, is actually the salt crystals. So the advantage of this method, that it saves our time. It does not take lot of time as compared to crystallization, in which when we crystallize, we have to remove all of the water until the salt is left behind. But here some of the salt still there, but because this can, in the beginning there was a greater quantity of the solvent, so it is having a solute dissolve in it. But when we remove the amount of the solvent, and as it cool down, the solid will appear, because this amount of solvent cannot dissolve too much solute. So that solid will crystallize and it will appear on in the container. We call this technique as crystallization. Is it clear? Clear to everyone? Any doubt? So if you want to separate, the soluble solute, so the two techniques are there. One is called crystallization, another one is known as evaporation. So a simple question is there related to this topic. Example, you have a sample of a rock salt. So there's a sample of a rock salt that contains sodium chloride and sand. So there is sodium chloride as well. In the rock salt, there's a sodium chloride and sand. Sodium chloride is soluble. They give you the idea that sodium chloride dissolves and sand does not dissolve in water. A student obtain a dry crystals of pure sodium chloride from a lump of rock salt. So student want, like he's having a rock salt. A rock salt is a mixture of what? It contains sodium chloride. Like example, the blue part is representing sodium chloride and the red part is representing, or a pink shade is representing, a sand. So this is representing, a pink shade is representing a sand and a blue is representing sodium chloride. And this mixture, a mixture of a sodium chloride and a sand, is called a rock salt. So a student obtain a dry crystals of pure sodium chloride from a lump of a rock salt, like he's having a large piece of rock salt. These are some steps the student use. So these are some of the steps student use. So first he grind the rock salt into smaller pieces, and what we call this apparatus, name the apparatus, label A in step 1, sorry. What we call this apparatus in the last part, we will discuss the name of the apparatus, but right now I will just type the answer. That is called mortar. And this substance, this is, if I say this B or C example, so this is called a pestle. You have to learn the labels of the apparatus as well. That we will do in the last part after completing the discussion of this chapter, this topic. We'll discuss the different type of apparatus used in the lab. So this is mortar and pestle. Explain why the mixture is heated and stirred in step 2. So what is the reason why we add a mixture and why we heat this mixture and stir? Stir means like when you take a spoon and mix, this is called stirring. So why we heat and stir this? The purpose of heating or stirring is to increase the rate of dissolving so that it can dissolve faster. So if you want to increase the rate of dissolving, what we can do, we can heat it and we can stir. That's why, like example, when you're adding a sugar to a cup of tea, then you stir by with a spoon. You stir. What is the purpose of the stir? Why not only just adding a sugar and left it same as it? Because if you leave a sugar crystals, just add to a cup of tea, it will not dissolve too much. If you want to dissolve faster, quicker, and greater quantity of a sugar, so you should stir. Is it clear till now, this part? So first we crush it and then we heat it and stir so that it can. In part B, Abdullah Surfraz, they're asking why we heat and stir the mixture. Like example, what is the purpose of stirring? What is the purpose of mixing with spoon or spatula? So what is the purpose of stirring the solution or mixing the solution? Whenever you stir or mix, the main purpose is to dissolve faster. It will not only dissolve, but it will dissolve faster. So if you want to increase the rate of dissolving, we stir the substance. Then name the apparatus, label B in step 3. So what we call this apparatus? What is the name of this apparatus? Pointed towards a funnel or a filter funnel. You can also say filter funnel or you can say funnel. Then state the scientific term for a sand left on the filter paper. What is the scientific term used for a sand which is left on the filter paper? We call that as a residue. And what is the scientific term for a liquid, a solution, a salt solution which passes through a filter paper? That we called as a filtrate. Then describe what student must do after step 3 to obtain dry crystals of pure sodium chloride. So basically what happened, I will repeat. First, a student is having a rock salt. Then he crushed the rock salt and stir so that the salt can dissolve. So now this is sodium chloride solution. This is dissolved sodium chloride. And this what is left is a sand. When he filtered, the sand will left on the filter paper. That is a residue. And what passes through is not only water, this will be sodium chloride salt solution. Because sodium chloride is dissolved, so it is sodium chloride solution. Now, sodium chloride is a soluble salt. How we can obtain a soluble salt from this mixture? So a technique which we can use evaporation or we can use crystallization. and it's of 3 marks, so you have to explain. Like, what we can do, it's up to you which technique you want to mention, but it's of 3 marks, so better mention crystallization, because crystallization is having parts. So we will use crystallization. Heat and concentrate the solution. Decanting cannot be used. Why decanting cannot be used? Because this is a salt solution. A salt solution cannot be decanted, as it is a soluble salt. If it was insoluble, then decanting can be used. They're asking, in the question, they're asking what you will do in step 3 to obtain a salt from this. So we want to obtain a salt from this salt solution. So if we want to obtain a salt from salt solution, we use crystallization. So you have to mention the points of crystallization. We will use crystallization. We will heat and concentrate the solution. To the point of crystallization means until the solid is formed, or it is, this is a scientific term used when the solids start to form from the solution. We call point of crystallization. So heat and concentrate the solution to point of crystallization. Then we will cool down the solution. We will filter and dry the salt. Is it clear? The technique of crystallization, as we just discussed, that if we have a salt solution, instead of removing all of the liquid, we remove small quantity of the liquid so that it can form a solid. So when a liquid can form some solid, we call that as a point of crystallization, which you have to learn. Any doubt till now? Yes, we can only we can separate if we have a, for example, look, you have a soluble solid. So this soluble solid, does, you cannot see any soluble, as it is a soluble solid, you don't see a solid here. But when you supply the heat energy, some of the liquid you evaporate. So when you remove some of the liquid, the solids start to form, because this liquid cannot dissolve, because small quantity of a liquid, so it cannot dissolve too much solid. So when it cannot dissolve too much solid, some of the soluble solid start to crystallize, and whenever we want to separate a solid from the liquid, we can use filtration. So filtration not only for insoluble, but it is also when you see a solid and you want to separate from the liquid, you can use filtration. So this was some of the dissolved salt which appear or left behind, cannot dissolve. So you can use filtration in this case as well. Yes, Abdullah?
Sir, but we can only filtrate unsoluble, but salt is soluble. How we can filtrate
Salt
it?
is soluble, but what happened, Abdullah? Look, for example, this amount of a liquid was containing 2 gram of a salt. Okay, there's a 2 gram of a salt inside dissolved. Clear? When you supply heat energy, you remove half of the liquid. So half of the liquid cannot dissolve that 2 gram, it can only dissolve 1 gram. So if it can dissolve 1 gram, what happened to remaining 1 gram? That remaining 1 gram will remain, will come out as a solid. Because I told you there is a limit to which a solvent can dissolve a solid. So in the beginning, 2 gram of a salt was dissolved in the whole container. But when you remove half of the solvent, you evaporated half of the solvent. So that remaining half cannot dissolve the same amount. It can dissolve less amount. So if it dissolve less amount, what happened to remaining? That remaining will crystallize or turn into solid. And that solid you can remove by filtration or decanting. Is it clear?
But sir, they haven't written the quantity of the salt.
Yeah, they haven't written the quantity of a salt, but this is what happened, that a salt is mixed in water, and when you remove the amount of this, you can perform at a home. What you will do, take a container, okay, and fill it with water. You can take a glass, fill it with water, and add salt, like say two tablespoon or of salt you will add, and stir and leave it for, like example, 5 days at one place. Leave it for 5 days. After 5 days you will find the amount of the water will decrease because the water evaporates. So when the amount of water decreases after 5 days, you will see some of the salt will appear. Some of the salt which you add will appear. That salt does not dissolve. Why? Because the amount of the quantity of a solvent decreases. That's why it cannot dissolve the same amount of salt in it. So as the amount of solvent decrease, the amount of salt dissolve will also decrease. So if it was having originally extra amount, that will crystallize and we can remove that by filtration. Is it clear? Yes, Abdullah? Sarfraz?
Yes, sir, clear.
Okay. So you can perform this at home as well. It's a simple experiment. Take a container, fill with water, add salt. It's up to you. Like example, 1 tablespoon or two. Stir it until the salt completely dissolve, and leave it for some time. Like five. Evaporation is a slow process, so if you supply heat energy by a Bunsen burner, then it will be fast. But you can leave it for some days, and after 5 or 7 a week, 7 days or a week, you will find that some of the salt crystallize, which we can remove by filtration. So today we discuss the two techniques, which are like five main techniques, but two techniques in terms of separating the substance. So if you want to separate the soluble, insoluble solute, no, it should not be left in the fridge to cool down. It's already a room temperature. You can keep it outside so it can evaporate by itself. You're not supplying heat energy. If you supply heat energy, then you put it outside to cool down. Otherwise, without supplying heat energy, you can leave it as it is. So if you have insoluble solute, which technique we use? We can use filtration, decanting. What else can be used? Centrifuging. If you want to separate the soluble solute, you can use evaporation, or you can use crystallization. These are the techniques we discussed today. Any question related to the class today? Any question or a doubt related to the class today? So tomorrow we'll discuss two more techniques, but that is to separate the solvent from the mixture, a solution, or separating two or more liquids from each other. So I'll end the session and share this recording with you.